In this grade 3 classroom, students inquire into the social studies topic of communities in Canada, 1780 to 1850, and the related concepts of social studies thinking, continuity and change, using a rich mathematics investigation. Throughout the unit, students examine the following questions. How are the longhouses in an Iroquois village at Crawford Lake, similar or different than your home? Do you think the challenges the Iroquois faced, and you face now, are the same? Why? Students explored ideas they had about the challenges of First Peoples and early settlers by posing their own questions, along with their teachers, on an inquiry wall. This is left up in the classroom so students can add, revise, or pose new questions at any time during the unit. These are partially stimulated by examining primary artifacts from First Nations historical sites.
They all look different, and I know this one's used for a shovel.
For what?
A shovel.
A shovel. Tell me what makes you think it's used for a shovel?
Because it could dig out stuff easily.
What else could it do?
Crush corn.
How would it crush corn? What else could it do?
Hammer.
Yeah, show me how it could be used for a hammer.
Like if you keep on patting it down hard, then you'll press it.
What else could it do?
I know.
Math problems are based on whatever we're studying, be it a novel, be it social studies or science. We try to tie in our language, whatever we're covering, with the strand we're covering. So if we're doing diaries, it's tied in with actual diaries, primary sources that we have from early settlers that we look at and compare. And we try and make everything
we had a
cross-curricular.
As if they were on the ship coming from England to Canada, the story about their first days and weeks here, what it was like establishing their settlement. And then, like you're saying, with math and the problems that we pose, it's just the setting.
As part of their inquiry, they conduct a mathematical investigation, where they learn about important relationships among measurement units, and about relationships involved in calculating the perimeters of a variety of shapes and figures.
Well, we had been on a class trip to Crawford Lake just the other day, and we had seen some longhouses that both the actual longhouses that were rebuilt and then the footprint of another couple. And so we had discussed that we thought this would be a nice way to tie it in with area or perimeter and let the kids take that real life experience and then kind of see if they could figure out how math would have been involved back then, even in a society that maybe wouldn't have figured out in the same way that we would today. So that's why we began the lesson talking about non-standard units of measurement. And hopefully they're making that connection with the idea that, yeah, they wouldn't have had rulers, they wouldn't have had surveyors to figure out how the lengths and widths went, but they then took what they would have done with the non-standard and moved it into something a bit more concrete and then planned out their village. Give them a finite amount of resources but also let them understand that everyone's would still be different within that, so that they had 220 meters of wood that they knew had built the perimeter of these longhouses, but that everyone's would still end up being different. That no two groups would be the same because there's so much variation within that.
Yeah, and it leaves the door open for further exploration. Whether we open it up to using it with the early settlers, homesteads, they can plan houses, barns, and that sort of thing. We can build on it and do more area work. Today was just perimeter, but we can link the two together, seeing how the relationship between perimeter and area.
What's the largest longhouse you can make, or sorry, the largest perimeter for a longhouse with the smallest area, and then vice versa. And let them play with that and really see how those things affect one another. Great. When those posts were dug underground, what remained that allowed them to see where the longhouses were? Yeah. Wasn't it an outline? Yeah. The soil was darker. Remember that being told us? The darker soil where they
when you're drawing your longhouses on the chart paper to show basically a map of your village, is there a way that you can make your drawings easier to understand from a card paper?
How long?
Yeah, it would be awesome if you labeled the dimensions of the longhouses. How many squares long, how many squares wide, and that's just going to help you decide what the perimeter is at the end.
We're making the fence wall around the village, and then we're going to make some log houses inside it. Yeah, they're sort of like the longhouses that when we went to Crawford Lake. They're sort of like the ones in Crawford Lake. Crawford Lake, they had outlines for 2 of them. So what we're gonna do is we're gonna make our 3 longhouses and then maybe outline 2 of them. 10, 20, 10, 20. Then we got to do 10 plus 20 plus 20 We're estimating how much it is. Our estimate in total is 60. We added them together. 20 is a meter on the side and 10 is the meter on the front and the back.
And they're equal because it's a rectangle, and in the rectangle they're equal. If one side's 20, then the other side is.
So how do you
Start figuring it out, okay? But that's what I'm more concerned with. So, what's the perimeter of each of these longhouses? No, don't worry about erasing it right now. Just tell me the perimeter of each, and then see how that relates to your total of 220. Okay?
In this group, a common misconception is revealed. Confusing units of area with units of length. They determined the perimeter to be 28 by counting each square as a unit of perimeter and counting the corner square as the 10th unit of length. They did this for all 4 corners, resulting in a perimeter of 28 rather than 24.
Instead of just measuring the whole thing like this, what I did is I forgot that. So what I did is I labeled my squares here. So the top is obviously 10 or 11, 4 or 5, 10 or 11, 4 or 5.
Okay, can you count for me?
Yep. So 1, 2, 3. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9.
And then that's
So 9.
That's 3. And then that's 3.
So that's 3 on that side?
Yep. And then can I just get over here, please? Can I? This one's 3.
And what's the other side? What do you think the other side is going to be?
I think it's gonna be 9.
Why do you say that?
Because this is 9, and then
I think this is 9.
equal, and then
Okay, check it out. Check it out.
So 1, 2, 3, 4, 5, 6, 7, 8, 9.
It is 9. All right.
No, you guys know.
Oh, I keep doing it. Hang on.
So what do you think this one's going to be?
this is going to be 3 because this is equal to this.
Okay. Let's just check that out.
Okay. 1, 2, 3. Okay.
Okay.
There you
So
go.
now how much do you have?
So, let me think here. 9, 18, 20, 21, 22, 23, 24.
The idea that they had a finite amount of resources with which to work. Yeah, how do you deal with a limited amount of resources? So that's another right one.
So there's a tie.
Students have many ways in which they can explore mathematics through a social studies focused inquiry on continuity and change.